Light with a wavelength of 500 nanometers, that tells us that lambda is 5 times 10 to the negative 7 meters, shines through a grating. The screen is 3 meters away, that tells us that L is 3. On the screen, the distance from the first to fourth bright spot. We've done this a few times now. Gratings, we usually talk about the bright spots. Since they're so narrow, that's the whole point of it. It's a little bit simpler to measure the location of that narrow thing. First to fourth is equivalent to 0th to third. So really, this is an n equals 3 case. The y that goes with that is 30 centimeters, which is 0.3 meters. You could doodle a little picture to convince yourself of that. If you doodle the little picture, you could go one step farther. If the 0 to third is 30 centimeters, then 0 to first would only be 10 centimeters. And you could use n equals 1 with a y of 0.1 meter. But for this one, I'm just going to roll with n equals 3, corresponding to y equals 0.3. And this question wants to know the distance between the openings, even though, oops, typo here, even though I'll fix it in the original document, openings of the grating. Now, when you look at the Google Doc, it won't say double slit, but I'm not going to redo this. I'll just keep rolling. We can figure out the d value of the grating the same way we would have for a double slit. That's why I had the typo, because it's the same method. dy over L equals n lambda. In this case, we know everything but the d. So it's d, the y I'm choosing to use is 0.3. The L was given as 3. A lot of 3's in this. The n was 3. And the lambda for this one was 5 times 10 to the negative 7 when we're in meters. Cranking all that out, doing some calculator work, I get a d of 1.5 times 10 to the negative 5 in meters. That's how we tackle a grating question. Sorry for the typo. We could go one step further. Usually a grating is given in terms of how many lines there are in 1 centimeter. If we wanted to go one step farther, we could give that value, how many lines there are in 1 centimeter. We just would have to plug in our d, and it's equal to 0.01 meters, or 1 centimeter, divided by the number of lines. If we do the math on that, it's not a clean number. We get that the number of lines is equal to 667 lines per centimeter. Since I subbed in 0.01, that's why it's lines per centimeters. How many lines are in 0.01 of a meter? I had to convert the 0.01. I had to convert that to meters to cancel out the meters in the 1.5 number. The way the question's worded, though, it didn't ask for that. I'm just sort of reminding you that extra step that happened in gratings. Usually the d is given, instead of directly as a d, as the number of lines per a distance. If we wanted to convert the other way, we could just do a little bit of logic and flip-flop and figure out the number.